Hey, Psych people. Oh, awesome. I just did a 20-minute lecture and it turned off. Awesome. Uh, Perfect. Anyway, you may notice I've got a little more shading on my face now so I don't look 90. Um, there's a psychological component to trying to pull this off, and probably the hardest part of that is the self-esteem needs an individual has, as we were talking about Maslow. And you look at yourself on tape and you're like, my God, I look 100. The good news with that is it makes you sort of look like, oh, well, I mean, whatever with this coronavirus, I guess it's my time. If I start to look at my old videos, I'm like, oh yeah, no wonder Corona. I'm the guy Corona's coming after. Anyway, just kidding. I guess it's too soon to joke about coronavirus, but you got to do something to stay sane. And I didn't gonna get any of you guys and ladies, and that makes me very happy. It's not gonna get me either because of my look at it. Anyway, I'm knocking on wood there. I don't know if it is or it isn't. I don't understand this stuff. I do know that you just gotta kind of live your life, man, and appreciate everything. That's your cura personalis right there. Live your life, appreciate everything. Anyway, I hope you really had a good time with that diagram I made of the neuron. There's nothing that kind of gets fired up like neural impulses and myelin and dendrites and synaptic spaces. So I know you've been fired up and you've been saying, well, it's Wednesday. It's been 2 days. Where's our next diagram? Get ready for your screenshot. Right there. There's your screenshot. Okay. So in the screenshot, we can see a frontal lobe. We can see a parietal lobe. We can see an occipital lobe. We can see a temporal lobe. Okay. Then we can see a hypothalamus and an amygdala. Those are sort of below and between the other parts of the brain. So you should have a great screenshot, and for the record, go get yourself a real diagram from someplace that is much more reputable than my drawing. Just because I have these and a child's pad does not make me an authority in any way. So let's talk about the brain, okay? Well, how do we see the brain? Well, we see the brain through something called an electroencephalogram, okay? And that takes a look at the electrical components of the brain, and we can see it light up. You can also get a magnetic resonance image of your brain, and that's an MRI. And many of you have had magnetic resonance images of your knees or your ankles or your elbow or whatever. So you are familiar with the MRI. If you're going to get one for the brain, it's going to be a very claustrophobic thing. But this is how we take a look at the brain. And I'm going to start down low, or, sort of, if the brain is here, we come down to the middle, okay, in between, and everything else, it's the colored part of the diagram, and then this sits inside, and this is called your limbic system. And this is very important to psychology because the limbic system houses the lateral and the ventromedial hypothalamus and the amygdala, okay? And the amygdala is where we get that aggression and fear. So in the case of, Paul, Paul Bucy, okay, not philosopher, psychologist, who actually manipulated a crazed chimp's amygdala to turn him into a mellow, sedated, chill, sort of hangout chimp that everybody could love. Okay, so that aggression and fear is typically associated with the amygdala, and the amygdala is obviously because of aggression and fear, the amygdala is very important. So, what we have here is we have a situation where the Bucy was able to kind of, I think he created a lesion, or did he use an electrical? I think he created a lesion in the amygdala that turned off the aggression that was linked to the chimp's fear. So that's why we're going to be looking at the amygdala. It's very important. And then we have the hypothalamus, and the hypothalamus is sort of this sort of coordinates your glandular stuff. It kind of takes it's your hunger, thirst. It tells your master gland, the pituitary gland, to emit the right chemicals within the bloodstream that will make you hungry or make you full. And that's typically a blood sugar thing, and anybody who's a diabetic understands the role of the pituitary gland in this whole thing. Well, James Olds and Peter Milner in 1954 stumbled upon a rat, and they decided to put an electrode in a part of the rat's brain. I know they made a mistake with where they put it. And what they found was that they could stimulate the rat's pleasure principle. Now, the hypothalamus is a major survival mechanism. So the hypothalamus will respond pleasurably to rewards. That's how you survive. It's the law of effect. And this rat apparently was willing to press a lever like 7,000 times in an hour to keep having that pleasure center stimulated. And they later figured out, oh damn, this isn't where we thought it was. This is in the lateral hypothalamus. Our sexual function is determined largely on a biological level by our hypothalamus's reaction, and it will then it sends a message from the brain to the glandular system to get aroused. And so between the hypothalamus and the amygdala, we're dealing with a lot of the emotional components of our being. Okay, so that's why these are really important. I know this isn't AP Psych, this is just regular Psych, and if it were AP Psych, we'd have to go into extreme depth as to the functions of all parts of the brain. But for the sake of general psychology, we kind of limit it to the hypothalamus, the amygdala, and the four lobes of the brain. Now, the four lobes of the brain, as I mentioned, are frontal, okay? And in the frontal lobe, you have a prefrontal cortex. And your frontal lobe is used largely for judgments and movements. Now, the judgment part is where teenagers get in trouble, okay? Because their prefrontal cortex is not fully developed. So that's where we start to get into a little bit of trouble. So that frontal lobe is developing in the teenager's brain, and their judgments are not what they should be, okay? On the side, we have your temporal lobes, which are, and by the way, it's mirrored. And remember that the right hemisphere, which would be left, wait, I'm pointing, I don't know what the hell I'm pointing at, but the right hemisphere controls the left side, left hemisphere controls the right side, but they are almost identical, and they are separated by something called the corpus callosum, which in itself can have issues and cause seizures, but we're not going there. Anyway, you've got that temporal lobe right here. Okay, it's your ear and hearing. Occipital lobe is behind, so if you kind of tap your head, it kind of affects your vision. If you get hit in the back of the head, it affects your vision. And the parietal is sort of behind the frontal. Okay, and this is where you get your touch and your body positioning stuff. The cerebral cortex is this thin layer of interconnected neural cells. Okay? Look at me pointing as if you can actually see my neural cells. No, but this is just out of habit. I'm sorry. Anyway, I'm gonna take a break here because I've been getting cut off by my iPhone. So I'm gonna upload them. This will be the completion of part 1. So this is part 1. Here's one more screenshot. And I'll be right back with part 2.